Hi, everyone. I'm Jeff Wagner, Technical Lead at Open Force Field, and this is our September infrastructure update. This month's update is a bit short because much of the team has been spending time on cross-training, where everybody learns how to fit a force field um, and better understand our fitting stack. But the infrastructure updates that we have for you are that Naggle charges support is out. This is a slight reminder from last month, but one change that's been made since then is that Naggle and Naggle models are now dependencies of the Open Force Field toolkit. So you can use these new charge models right out of the box when you want. Um, and if you don't want that, if the download size or the installation is too large, you can use the OpenFF toolkit base package and then bring in dependencies specifically just for what you need. This will pave the way for the OpenFF 2.3.0 release, and you'll be hearing about the release candidate soon from Lily. And as a reminder, the form that Naggle charges goes into an OFF XML file is basically it replaces the toolkit AM1 BCC field, and instead it specifies a Naggle model file name and optionally an online digital object identifier at Zenodo, where the file name can be retrieved if it's not available locally via Conda installation. We've also put a lot of effort into continuing work with OpenFE on protein force field benchmarking. And so specifically, we're helping Irfan Alibay at OpenFE prototype Smirnov protein support. This is important because it will enable us to do free energy benchmarks of Chapin's protein and small molecule force fields. This is the effort that we will use to create the Rosemary force field, OpenFF 3.0 currently. And so it's important that we be able to have a quick turnaround as these candidate force fields improve in protein-specific benchmarks that we're able to do protein ligand binding for energy benchmarks to select a good release candidate. This effort also serves as initial work towards eventual Smirnov protein support in OpenFE. This effort by itself is a prototype, and we're turning up lots of really useful information for debugging. But once we have this in, this prototype will be really useful for mainline support. As part of this effort in the past month, we've been validating the prototype protocol by running benchmarks against the mainline OpenFE. So where mainline OpenFE uses the FF14SB file from OpenMM and the Smirnov template generator, we can use the FF14SB port in Smirnov format and the same Smirnov force field and make sure that the same numbers come out of the free energy calculations. This is actually quite sensitive, and it turned up a subtle bug in interchange.combine where sometimes constraints, like bond length constraints from the two things that are being combined, one could overwrite the other. So that was fixed a couple weeks ago in interchange 046. We are seeing still a higher error rate with the prototype protocol. And we're thinking that's because of our use of PACMOL for solvating the system. There are a couple technical considerations that led us to choose PACMOL, and it's looking like it does some funny stuff with water ion placement. We're not quite sure, but to have a more apples to apples comparison with mainline OpenFE, we're just implementing solvation using OpenMM. So hopefully we'll have more to tell you about in the next month. Again, currently the team's doing a bit of cross-training where people are actually undertaking significant force field fitting experiments so that we can learn more about our stack and improve our bus factor and hopefully get more informed voices in our force field fitting. Thank you very much.